will start with a gland which is called as pancreas. So, in the beginning of the session we have talked about that generally glands can be of two types, one is the exocrine and endocrine. So, we have given the basic differences between an exocrine gland and an endocrine gland. So, exocrine gland will generally produces juices, endocrine gland will produces hormone, and they have got duct. Which one? Exocrine. Endocrine doesn't have duct, right? And exocrine secretions will happen at any time. For example, the best example for exocrine gland is salivary gland. So, saliva, what is the purpose of saliva? Main purpose is digestion. So, even if there is no food, okay, the salivary secretions will keep happening, but hormones are not like that. Hormones will be produced only when there is a need. Getting my point? When blood glucose level rises, insulin will be produced, because the major purpose of insulin is to reduce the blood glucose level, and it will be produced in very trace amount. So, we have seen what are the characteristic feature of hormone. Okay, so they are produced by endocrine gland, they will be produced in trace amount, they are non-nutrient. Okay, in case of any nutritional deficiency or energy requirement, hormones are not suggested to be consumed, right? So, my point here is, why I am talking here is, there are two types of gland, one is exocrine and endocrine. Your pancreas is both the exocrine and endocrine. Okay, see, pancreas is a composite gland which act as both exocrine and endocrine. We also call this as a dual gland. Okay, we also call this as a dual gland, which is both exocrine and endocrine. So, the exocrine part, okay, of it will come under digestive physiology. Right, will come under digestive physiology, exocrine part, like what are the secretions of pancreas with respect to digestion, like pancreatic amylase, trypsin, chymotrypsin, etc. And unfortunately, that very good chapter has got deleted from the present syllabus, but anyway, the exocrine part, it will come there. Whereas we in this chapter are concerned with the endocrine part of pancreas, right? So, the endocrine part of pancreas is referred as, see, islets of Langerhans, islets. The S is silent here, so you call it as an islets of Langerhans, which is very minimal, compared to exocrine. So, when you compare exocrine and endocrine, almost 96-97% of pancreas is made up of exocrine, whereas endocrine islets of Langerhans is just some remaining 3 to 4%. I am not sure of exact value, but I am pretty sure that more than 95 is going to be exocrine and around less than 5 is going to be the endocrine, right? Now, they have mentioned there are about 1 to 2 millions of islets of Langerhans in normal human pancreas, representing 1 to 2%. See here, it is just not even 5%, it is just occupying 1 to 2% of the pancreatic tissue. So, remaining everything is occupied by the, which one? Exocrine part. See, when you see some value, you have to note it. When you see some example, you have to note it. When you see some exception, you have to note it. So, that is the critically you have to view the NCERT book, right? Okay, fine. Isn't here. Now, actually, this islets of Langerhans has got different types of endocrine cells, like you can say alpha cell, beta cell, gamma cell and delta cell, right? Alpha cells are known to produce a hormone called as glucagon, right? Glucagon. Beta cells will produce hormone called as insulin, and this is going to produce a hormone called as somatostatin, right? Somatostatin. And delta cells will produce something called as pancreatic polypeptide. So, these are all the different hormones from the different cells of islets of Langerhans, right? And among this, the exact function of pancreatic polypeptide produced by the delta cells is not yet understood. Why there is a such type of hormone there? Okay, still the research keeps happening to understand, okay, the role of this pancreatic polypeptide. Whereas somatostatin, if you take somatostatin, generally somatostatin has got a negative role. Like, if somatostatin is produced by the gamma cell, the adjacent is going to be either alpha or beta cells. It is going to inhibit the secretion of alpha and beta cells. So, for example, if I am the gamma cell, you are the beta cell, you produce insulin, I produce somatostatin. So once I produce somatostatin, it is going to act on the adjacent cell, adjacent or nearby cell, right, and it is going to stop the secretion of that particular cell. So there are 3 to 4 contexts where you get this thing, somatostatin. Everywhere the hormone will reach the surrounding areas and it will try to inhibit that secretion, right? Okay, and you also see an insulin and glucagon, of which we are pretty much interested with insulin and glucagon because both are involved in glucose metabolism. Already we have talked about something related to cortisol. It is also called as glucocorticoid. So there are many hormones that is going to play a significant role in glucose metabolism. Like growth hormone play a role in glucose. Growth hormone is not just destined to make us physically grow. Apart from that, it also has got some role in metabolism, of which it plays a significant role in glucose metabolism, right? So in this glucagon and insulin, like we had yesterday, parathyroid hormone and calcitonin. Okay, parathyroid hormone and calcitonin both play a role in calcium metabolism. Aldosterone is going to play in mineral, that is sodium and potassium, water. Likewise, this insulin and glucagon is going to play an important role in glucose metabolism. Clear, Arka? Right? Now, see, this is the intestine. So let's have a very small discussion for 5 minutes before we get into the exact details, right? So it's going to be intestine, and this is going to be the blood, right? And you have whatever food that you consume. So today I had rice. What is rice made up of? Starch. Carbohydrate na starch. What is starch? It is the mix of glucose. So when I consume starch, my enzymatic enzymes involved in digestive system, it is going to break the starch, which is the complex of many glucose molecule. Let's assume it as 1000. This is going to break the glucose, starch into individual glucose molecule, which is present at the intestine. So this is going to be the intestine. Now the glucose molecule from intestine enters into the blood, right? Now I have a word here called as BGL. What is BGL? Blood glucose level. Now when this happens, I call this as an absorption. So when absorption happens, what happens to BGL? Increases or decreases? Excellent. So BGL is going to increase, right? And as I said, when BGL increases, the glucose in that has got a two fate. One, it has to get utilized. I gave you an example in previous cases. For example, I have had my food at 5 p.m. Now at 7:30 I am going to have one more food. So whatever the glucose that enters into my blood will get stored because I am full with energy. You are getting the point, right? So now this blood glucose, whichever molecule enters, has got two fate. One, it is utilized, I will call it as U, or it gets stored as S. So once that depends on the energy requirement, right? So say assume that I had my food at morning 8 and I am fasting till now. I am hungry. So whatever food that I take will get utilized because I need. See, you need 100 rupee. I am giving 200. What do? You use 100 and store the remaining 100. Simple phenomenon, right? Now assume that it's getting stored. Then it gets usually stored in muscle and liver. Muscle and liver as glycogen. Right, as glycogen. So glucose will get converted to glycogen. Okay, this is something similar to starch, which is made up of many number of glucose molecule, but some bonding and some chemistry is going to be different. See, many glucose starch, many glucose glycogen. I can say technically polymer of glucose starch. Polymer, no, many monomer is going to be glucose. Polymer of glucose starch, polymer of glucose glycogen, polymer of glucose cellulose. So if you see all these complex biomolecules, everything is made up of glucose. But what exact difference here is the alpha, beta, your chemistry biomolecule will teach you all those things. So some chemistry difference is what is here. Rest of basically everything is made up of glucose. That is going to be one and the same, right? Now, okay, now in case there is a need, what happens? This glucose will enter further into the cell. Okay, this glucose will further enter into the cell. Okay, so assume that this is a cell where your glucose will get converted to which one? Energy. Okay, G to E through glycolysis, link reaction, Krebs cycle, which we call it as a cellular respiration. Right, cellular respiration. So this is the general thing, right? Now, this glucose to glycogen, right? This step is called as glycogenesis. It is called as glycogenesis, means formation. Formation of glycogen is called as glycogenesis. So when there is a need, why do glucose is getting stored? When there is a need, glycogen should break down to glucose. I have some excess money, I am going to store it in bank. What is my intention of storage? I mean saving it. So when there is a need, I am going to bring it, liquefy it and then use it for my purpose, right? So when there is a need, the glycogen will get back into the glucose. This is what is called as glycogenolysis. You are getting the term glycogenolysis. And other one is, as I said, sometime new glucose formation can happen. Yesterday we have talked about the term which is called as gluconeogenesis. Right, gluconeogenesis. So these are all certain basic terms that you have to understand here, right? Glycogenesis, glycogenolysis, gluconeogenesis, right? Okay, right. Now, with this situation, let's take insulin. The main purpose of insulin is to lower the blood glucose level. That's the reason why people who have hyperglycemia. What is hyperglycemia? Hyper means higher. Hyperthyroidism, hypercalcemia. Hyper means higher, right? We say why are hyperactive? Why are active? Solrón, yeah. So people who have got a prolonged hyperglycemia, they are called as diabetic mellitus. Diabetes mellitus, right? So for those people, they used to usually get themselves administered with some loads of insulin. So what is the intention there? The insulin that the person administers is going to bring back the blood glucose level down, right? Now what happens here is insulin, okay, is going to bring down the blood glucose level. Clear, Arka? And before that, what is this molecule? Glucose. This is entering into the cell. This is what is called as cellular uptake. Right, you know, cellular uptake or entry of which one? Glucose. Clear, Arka? Now we have got, this is one step, this is two step, this is three step, this is going to be fourth step. Okay, cellular uptake of glucose. Now let's take insulin. The main purpose of insulin is to bring down the blood glucose level. So what is the role of insulin on the cellular uptake of glucose? Whether the insulin is going to promote no action or it is going to not allow the glucose to enter into the cell. What is the idea here? Yeah. Assume that there's going to be 10 glucose here, 5 glucose enters into the cell. So what happens to BGL? Huh? Decrease or increase? I have 10 molecule of glucose in blood, of which 5 molecule enters into the cell. Then what happens to the blood glucose level? Decreases. What is the intention of insulin here? Blood uptake should? Uptake increase panuma, insulin pannada. Uptake பண்ணும்போது BGL குறையுது இல்லப்பா. Insulin intention is that, right? So I am a security, this is cell, that is corridor, right? There are 15 members here. As a security, you know what is happening in JIPMER. So my purpose is to reduce the number of people in the corridor. So I should promote their entry into this room or what? அதானே இங்க நீ இல்லங்கற அப்புறம் எஸ்ங்கற நீ ஏன் டிவைஸா சொல்ற நான் சொல்றது புரியுதா if more glucose is getting into the cell BGL will decrease. That is the intention of insulin. What is the intention of insulin? Decrease the blood glucose level. So insulin favors the uptake of glucose. சொல்றது புரியுதா when more glucose enters into the cell the number of glucose in blood will come down. As more people in corridor gets into the room the crowd in the corridor is going to come down. Purida. Now in this process there is a something called as receptor. I can say it is called as transporter. This transporter should open, then only the glucose uptake will happen. Purida. This is what is called as GLUT transporter. GLUT, glucose transporter. This is like a lock. So insulin is the key. So when this GLUT is open, more insulin will get into the cell. Purida, clear arka? What is the coming to here? What is the role of insulin on glycogenesis? Whether it is going to activate or deactivate. What is glycogenesis?
Conversion of glucose to glycogen.
And where is glycogen stored? When more glucose which is there in blood is getting converted to glycogen and it is getting stored in muscle and liver, what happens to blood glucose level? Decreases. So insulin is in favor of it. So insulin is going to promote this. How about glycogenolysis? Glycogen to glucose. That is going to increase the blood glucose level. So when more glycogen is getting broken down, if I am going to bring more money from my savings, my packet money is going to increase. Something like that. What happens to insulin with respect to this? It is going to block this. And gluconeogenesis is nothing but the formation of new glucose, and that is also getting blocked. Purida, this mechanism. Glucagon abde ulta. Because glucagon is going to increase the blood glucose level. That's the reason why glucagon is called as hyperglycemic hormone. Right? It is called as hyperglycemic hormone. But one thing, I am pretty sure that glucagon is going to block this glycogenesis, activate glycogenolysis and activate gluconeogenesis, but I am not sure whether insulin is going to favor the uptake of glucose. Glucagon, whether it is going to not favor or it is going to have no effect with respect to that uptake of glucose. That I am not sure, right? But this is how generally this hormone is going to act. So one is going to increase the blood glucose level, other is going to decrease the blood glucose level. Since both are produced at normal amount, blood glucose level will be maintained. Clear arka? Purida, the 4 step purida, right? Okay. So glucagon is a peptide. Peptide hormone means it is sequence of amino acids, right? And play an important role in maintaining normal blood glucose level. Glucagon mainly acts as a liver cell hepatocytes and stimulates glycogenolysis. Okay, and resulting in increased blood glucose level, which is hyperglycemia. In addition to this hormone stimulates the process of gluconeogenesis. Everything is given. Hence it is called as an hyperglycemic hormone. So whatever I have discussed here is what is mentioned here, right? And they have given insulin is also a peptide. Peptide means they are made up of amino acids in a particular chain. Actually, we have seen 3 different chemical types of hormone. One is the peptide, amino acid derivative. There is one amino acid which is modified here and there, that becomes an hormone, right? Other one is steroid, which is made up of a ring called a CPP ring. You remember that, okay? Right. So regulation of glucose homeostasis. Insulin mainly acts as an hepatocytes and adipocytes and enhances the cellular glucose uptake and utilization. அதாவது அவன் என்ன சொல்றான், இங்க பார், insulin is going to not only increase the uptake of glucose uptake மட்டும் ஆச்சு அப்படின்னா பத்தாது, glucose utilize ஆகணும். Utilize ஆகிறதுக்கு what glucose should immediately undergo? Glycolysis. I am bringing 10 members. There are 10 members crowded. I am bringing 8 members here. If 8 members are going to be permanent here, again the number of persons in that corridor is going to increase. So whoever I am bringing here, I am going to send them out. So there is a vacancy here, so that more people can come here. புரியுதா? அதில் you have a reaction called as phosphofructokinase glycolysis that is getting stimulated by insulin. So glycolysis will be enhanced. So glucose, whatever glucose that enter will become pyruvic acid, acetyl CoA, further into energy. So glucose vacancy will be created. So more glucose will enter from blood into the cell. சொல்றது புரியுதா? கிளியரா இருக்கா? ஓகே, அதெல்லாம் தான் இங்க கொடுத்துருக்கு, ரைட்? As a result, there is a rapid movement of glucose from blood to hepatocytes and adipocytes, so again decreased blood glucose level, which is called as hypoglycemia and other aspects, right? And listen dear, normal, this is how the insulin glucagon is going to play a role, and normal blood glucose level at 10 hours of fasting is going to be 70 to 110 milligram per deciliter is going to be the normal blood glucose level after 10 hours of fasting. See, our Indian generally follows the American Diabetic Association. So people who take blood glucose, sugar test, they have to at least fast for 10 hours. Then they have to give their blood sample, with which they should have 70 to 110. Assume that they are going to have their food by 8 p.m. So 6 a.m. they have to take. If you are going to have their food by 9 p.m., 10 p.m. and then morning 6 o'clock, now how much hour do they fast? 8. So they might have elevated value. So 70 to 110 is going to be normal. And after food, say 1.5 hours, 2 hours, should be around 150, 140 milligram per deciliter. So if there is going to be an increase in this level, then it is called as hyperglycemia. புரியுதா நான் சொல்றது? Hyperna enna adigam, hyperglycemia. When if there is going to be any elevated in this value is what is called as hyperglycemia. Generally hyperglycemia happens for everyone at some point of time. Say I have sumptuous food, I may be hyperglycemic. But when there is a prolonged hyperglycemia, consistent hyperglycemia, then that result in a condition called as diabetes mellitus. Listen, whatever excess glucose, usually whatever glucose is there in the blood will get to the nephron, which is there in the kidney for getting excreted. But since glucose is a very useful molecule, the nephron tries to bring back the glucose, the kidney will try to bring back the glucose from the tubule back to the blood. அதான் இதுக்கு reabsorption னு பார்த்தோம். புரியுதா? கிளியரா இருக்கா? glucose ஓட excess ஆகும்போது என்ன ஆகும்? all excess glucose will get out through urine. This is what is called as mellitus, diabetes mellitus, sweet urine னு அர்த்தம். கிளியரா இருக்கா? See, just not be that much into it. So what are the which is associated with loss of glucose? கொடுத்திருக்காங்க loss of glucose through urine. When glucose, see this you will come across in excretory physiology. When glucose level, simple சொன்னா 2 minutes, blood has got useful substance, useless substance. Say I have a bag, it has got useful, useless. I am cleaning it. What I am supposed to do? Put the useful, retain the useful, throw the useless. Likewise, blood has got both useful and useless. Kidney has to separate useful and useless. Adula blood glucose is useful, urea is useless. So send the urea out through urine. Glucose is useful, retain the glucose. Appo retain போது if glucose load is normal, then kidney can somehow manage in bringing back the glucose to the body. அதுவே அதிகமா இருந்ததுனா then kidney will there is lot of glucose, how can I bring it back? Then some glucose will get out through urine. For example, I can clear what is that in my bag I have got some useful substances, but useful substances are more. அப்படிங்கும்போது I am trying to retain the useful substance, but அதிகமா இருக்கும்போது என்ன பண்ண, some useful substances I am also throwing it out. So I can maximum 10 useful substances I can retain my bag, but I have 25. So remaining 15 என்ன பண்ணனும்? throw பண்ணனும். அதான் இங்க. அப்ப throw பண்ணும்போது whatever I am discarding, my discard will also have both useless and useful. சொல்றது புரியுதா? அந்த மாதிரி இங்க யூரின், அதாவது குளுக்கோஸ் லெவல் பிளட்ல அதிகமாக அது யூரின் வழியா கிட்னிக்கு ஒரு லிமிட் இருக்கு, அது வரைக்கும் தான் ரீஅப்சார்ப் பண்ணும். அதுக்கு மேல என்ன ஆகும்? குளுக்கோஸ் will be seen in urine. அதுக்கு பேர் தான் கிளைகோஸ்யூரியான்னு பேர். இங்கே கொடுத்துருக்கோம், கிளைகோஸ்யூரியா கொடுக்கல, it is called as glycosuria, presence of glucose in urine. Okay, and formation of harmful compounds such as ketone body. Diabetic patients are successfully treated with insulin therapy, right? Though it is given generally, my point is life with, see, diabetes there are two types, type 1, type 2. right? Whatever be the case, people who have got good lifestyle can slowly get rid of the medication. Not that every person who is diabetic has to consume some tablets, take some pills or insulin. If you have proper food, proper lifestyle, proper exercise, then that itself is going to help you in maintaining the blood glucose level, that is the diabetic mellitus. So this is what related to pancreas, right?